In this lecture, we are going to see a new data structure called hash data structure. What is this hash actually? Basically, we have seen several data structures so far related to the searching and insertion. And insertion and searching is within a constant time or within the log time or within n square time. So we have seen various data structures, especially to store the data and to retrieve the data as fast as possible. And this storing of the data and retrieving, this will be done from the main memory of the computer. That means so far whatever the data structures you have seen so far are all storing the data in the main memory. And there exists some data structures which may store the data on the hard disk, just like our B plus trees, where the data will be available on the hard disk, but its reference will be there in the main memory. Today we are going to start with a data structure which is intended to identify which is intended to insert and delete and at the same time searching an element within a constant average time. If you look at binary trees, binary search trees, AVL trees, they are all there are all some data structures like which is having some balancing factor, which is having some conditions, and whatever the element you are inserting based upon the condition that will be inserted into the tree. And when you are deleting, obviously some conditions need to be checked, and you are supposed to take care of the its children's and left child, right child, parent. So many factors will be there. Finally, this insertion and searching will be getting the complexity as a log n. In case of binary trees, binary search trees, AVL trees, etc. While coming to the B trees concept, in B trees also we try to reduce the height of the B tree so that the insertion and searching complexity will be order of log n to the base m, where n is the number of elements and m is the order of the B tree. Thereby, we try to reduce the searching time of an element. And in the same time, we have seen improvement of the B tree, such as B plus tree. But today, whatever the data structure we are seeing is a data structure which will store the or insert the elements and search the elements within a constant average time. You may surprise that how it can be done in a constant average time. So always, if you have the constant average time complexity, then such data structures are very efficient data structures. Because if I have given you an array, for example, if the array is like this, let I am going to declare an array int a of 10 or a of 5, let's say for example, is equal to 1 comma 2 comma 3 comma 4 comma 5. So whenever I declare an array like this, then how can I represent or how can I get the value 4? Here the 4 is the value which is at the position 0, 1, 2, 3. So whenever I say printf percentile d a of 3, then I will get the value 4. It means you are going to pick up an element within a constant time. Here the time complexity is you are not going through 0 to 4, okay, or 0 to 5, but straight away by mentioning the index. That means you are going to mention the starting address, that is a plus index. So thereby it is forming as a of index. Directly it is pointing to the location that is 3. Location 3. That means directly constant time. This is a very constant time that we are going to get the element. At the same time, to insert the element, scanf percentile d ampersand a of 3. So if I say like this, then the whatever the element you are going to scan, that will be directly placed in the third position of an array. So that means you are going to retrieve and insert it. At the same time, finding also will be done in the constant average time. So we are going to look at the data structure called hash data structure, which will maintain a array like this. Hash data structure will maintain an array, and by using some simplified formulas, we are going to identify what is the suitable index to insert the element into that particular array. This particular array is called hash data structure, and the process of using the formulas to calculating the index is said to be hashing. This entire hash data structure, like array, it will be stored in the main memory. So we are going to perform some simple calculations, especially to identify suitable position to insert an element into the array, and we are going to retrieve that element by performing the same operation again to get the element within a constant average time. This is what the basic idea of hashing. In this hashing, this is a very simple procedure, but in this hashing, we'll come across some problems, and there exist some solutions to overcome those problems. So all put together, in this particular lecture, we are going to see what are the different styles of hashing, what are the problems with hashing, how we are going to resolve those problems, and the related programs in this particular topic. Now we will see what is this data structure, hash data structure. This hash data structure is also said to be hashing in general. You will find the terminology as hashing in any of the textbook of data structures and algorithms. Hashing is a technique used to implement the insertion of an element and searching of an element within a constant average time. Note that the implementation of hash table is frequently called as hashing. That means either you may call it as hash data structure or hash table or hashing, all are one and the same. Hash table, a part of memory. It is just like an array. It is a part of memory called as hash table. Instead of array, we are calling it as a hash table. This is the only difference. Okay. Instead of array, we are calling this as a hash table, which is the part of memory. It is just like an array, memory allocation in array. In hash table, piece of memory is called bucket. That means the slot that what we are going to say in an array is said to be a bucket. A bucket can be divided into some parts. Again, that slot can be divided into some parts. Each part of the bucket is called slot. Okay. So assume that this is an array. This is an array kind of thing, and array slot, and this slot can be divided into categories. It is just like a structure array. In that we will be having one slot for one variable, another slot for another variable, another slot for another variable. All put together, this entire record is said to be a bucket. This is what the notation of the hash table. So I hope by this time you're clear that what is meant by hash table. Hash table is just like an array which will store in main memory, and what we call a slot in an array, here we will call it as a bucket, and this particular bucket will be having several slots. You can insert various values in it. This is what the basic idea of hash table. So array will be like this: x of 0, x of 1. If you declare an array of x, total number of buckets in hash table is equal to the size of the hash table. So how many buckets are there? That means the size of the hash table. That is the table size. Placing elements in hash table is by using the hash function. In case of array, we will take an index value called I or something, and we'll keep on. First, you initialize that I value is equal to 0. Then we'll increment the I value till you reach the key size, and you are going to insert the elements into the array. Whenever you want to pick an element at a 3, directly the array of 3, directly you will get the element. But here, to insert an element into an array, we will use a function called hash function. That means this is a simple numerical which will help us to find a suitable slot to insert into the element, insert into the array. The reason is, initially here a of 3 is 4, but whenever I say a of 3 is equal to 40, then obviously a of 3 is equal to 40 means this slot of 40, this element 40 will be overwritten on 4. Thereby, from the next reading onwards, you will read a of 3 as 40 only, but the previous element will be gone. But whenever we are inserting an element, obviously that element must be persisted. That means if you should not overwrite, we should not overwrite already allocated slots. So to not to overwrite already allocated slots, we are using a function called hash function, which will create, which will observe or which will identify a suitable slot where there exists an emptiness. In that, the inserting element will be inserted, so that you will not have any problem of losing the previous data. This is what the hash function. So the hash function is a mapping that maps an identifier or key in the sense that is the element that you are going to insert, key into the address of the hash table. This hash table, on basis of the key value, the hash function is replaced by h of x is equal to mu, where x is the key and mu is the numerical with which you are going to compute, say formula with which you are going to compute the index value. So where x is the key and mu is a hash function generated address for storing the record in hash table. A simple hash function will be like this: integer hash of constant string key. So the key may be an integer key or maybe a string, maybe a character, maybe of anything. Now int table size. So what is this table size? This is the table size. So int table size, initially this hash value is initialized to 0. For I is equal to 0, I less than key length means you are going to insert a string. A string may be having some certain length. You are going to read character by character in the string, and you are going to do some manipulation, and thereby you are going to get the hash value. The hash value will be like this: hash value plus is equal to key of I. So here key of I is a character reading. That means whenever you have, for example, you have inserted a string called hello. That means you are going to read key of 0 means H, then key of 1 is E. Like that, you are going to read character by character. And obviously, whenever you read this character by character, whenever you are adding with the integer, by default, it will be converted into ASCII character. As per ASCII character, H may be having some value of 70 or 71 or something. Then corresponding values will be added, and finally you will get the total value, and this total value will be moduloed with the table size. Assume that you have achieved a total value of 123, and assume that you may not get 123, you may get more than 123 or 1230, assume that, and the table size is 11. That means you might have taken a hash table of size 11. So 1230 modulo 11, whatever the resultant value will get, that is whatever remainder after dividing with 1230 by 11, whatever the remainder you will get, that is the modulo value. That modulo value is the index. That means always modulo will return a value between 0 to the size minus 1. So that is the reason we are going to modulo with 11 here, so that we will get an index value, so that the string what we are going to insert will be injected into that particular slot. Here in our context it is bucket, in that particular bucket. So this is the way this formula will work to calculate the suitable index value to insert the string. So in this process we have several methods to work with. Several kind of hash functions are in use, such as, so you may use a modulo, or you may use any of the function which will not give you any trouble in inserting the elements. In this, the most commonly used method is direct addressing. Direct addressing means directly we are pointing out an index and inserting the elements. Direct addressing, to calculate hash value to insert x in the table, simple, we can use the following function: h of x is equal to x. It is just like a of 3 is equal to 40. Directly we are going to insert the element into the location 3, like that. But it suffers with a problem that if index of a table are 0 to 999 and the key value is greater than 1000, then the function fails to identify bucket for inserting the record. Obviously, if you get an element which is greater than, or which you are going to insert in a key which is greater than the size of the table, then it is a problem that we cannot insert the element into the table. So this is what the this is what the main problem with the direct addressing. The next category is modular arithmetic. So obviously we have seen an example of modular arithmetic. So modular arithmetic, whatever the key size it may be, or key value it may be, obviously you are going to modulo with the table size, so that you will always get an index value which is between 0 to table size. So this is a most commonly used method which is called modulo method. The modulo method will be like this: h of x is equal to the key, x is a key, x mod t size, which is called table size. Next method is folding. Folding means if the value of x is very large, then the table size, this method may be suitable. In this, the identifier x partitioned into several parts of possibly equal size. Then possibly in equal size. Example, the table size is 1000. Assume that the table size is 1000. That means there exists buckets from 0 to 999. If the identifier or key is 6, 2, 5, 3, 8, 1, 9, 4. So this is the big key that we are going to insert into the hash table. We are trying to insert into the hash table. But there exists only few slots. So if you use direct addressing, what will happen? Obviously, the size of the hash table is not sufficient to insert the key. So we may go for modulo arithmetic. Modulo arithmetic is also fine. We can modulo this 625389194, this key, with the size of the hash table. So you will get some number, and obviously you may insert that this key in the particular slot. Is there any alternative method to insert an element? Obviously, this is the folding method is one more alternative that we may use, in which it may be divided. This particular key may be divided into 3 digit parts. So what are the 3 digit parts? 625 is 1 digit, one particular number. 381 is one number, and 94 means this is divided into 3 slots. Okay, this is divided into 3 slots. Whenever three sections, not slots. Okay, 3 sections. So 625, 381, and 94. Now these 3 will be added together. Whenever you add it, then 1, 1, 0, and 0 you will get. Anyhow, we have fixed that whatever the number we get should be divided into or segregated into 3 digits. So anyhow, we have 1, 1, 0, and you segregated 0. So 110 and 0. So you got 110 here. So the identifier 625381994 is inserted into the hash value 110. That means it is this particular element is going to insert into the position 110, that is the bucket 110, when the size of the hash table is between 0 to 99. So this is the way a folding method works. You can take whatever the size of the folding size or folding number of bits depending upon the length of the key. If the key length is 12, you may take four size, that is 4 digits by 4 digits. You may divide and add all those digits, all those numbers. You will get some summed number, and in the summed number also, if it is crossing the required size, then again you may fold it again. So finally, whatever the value you will get, that is the index value in which you are supposed to insert the key. This is one method. Next method available is mid-square method. Mid-square method means the hash function is computed by squaring the identifier or key and then using an appropriate number of bits from the middle of the result, taking number of bits or digits depending upon the table size. So here also the number of digits to fold is also depending upon the key size and also the table size. Here maximum table size is in 3 digits, so that is the reason we have taken 3 digits. Okay, if the maximum table size is in 4 digits, then obviously 4 digit indexes are available, so we can apply 4 digit here. Okay, so this is the way we are going to divide it. So in this mid-square method, the taking of the number of bits or digits depending upon the table size. Example, if the key is 1, 2, 3, 4, 5, 6, this key need to be inserted. Where this digit gives the value 1, 5, 2, 4, 1, 3, 8, 3, 9, 3, 6. That means this 1, 2, 3, 4, 5, 6 should be squared so that you will get this particular value. From this particular value, you pick the middle 3 digits. Okay, you pick the middle 3 digits. So if a 3-digit address is required position 5 through 7 could be chosen given the address 138. That means this 1, 2, 3, 4, 5, 6 is the key will be inserted into the index 138. So here in the hashing and finding the indexes, we have seen 4 methods. One is direct addressing, another is modulo arithmetic, here folding, and mid-square method. But out of all these 4 methods, we find modulo method is very simple and easily we can get the index value. The reason is the computation is very simple. Simple modulo operation you are supposed to perform. So that is the reason modulo operation is more famous in calculating the index value than folding, direct addressing, and mid-square methods. Note, it is a good idea to ensure that the table size is a prime number. The reason is, if you keep the table size as prime number, you will not get any collision. That means, for example, if I have the values 40, 60, 70, then my table size is 10. Then whenever you want to insert into the table 40 modulo 10, which will give you 0, 60 modulo 10, which will give you the value 0, 70 modulo 10, which will give you the value 0. It means here you have the variables x1, x2, x3 and t size. That means if you perform hash of x1, then whatever the value will get, which is equal to the hash of value x2. That means whatever the hash function I have used, 40 modulo 10, you got 0, 60 modulo 10, you got 0, 70 modulo 10, you got 0. But whenever, based upon this index value, if I try to insert this element, obviously in the first attempt, the 40 may be inserted since the table may be empty or slot 0 may be empty. But whenever I try to insert 60, obviously already that 0 slot is occupied with 40, so you cannot insert the 60 element in that place. Thereby what will happen? It will lead to a collision. So whenever you have the elements x1, x2, x3 and the t size, that is the hash table size, then computing of h of x1 is equal to h of x2 for all x1 not equal to x2, then it is said to be collision. It is said to be collision. So it is just like you might have seen in many of the situations, especially when you are traveling in train. Okay, they may mistakenly come to your compartment and they will say that, okay, this is my seat. Okay, you have to get up. So finally, after there is some collision and some clash will happen. Since we are human being, okay, we try to resolve that. What is your compartment number? Whether it is S1 or S2 or S3. Okay, then we'll resolve it that, okay, that fellow may be mistaken that, okay, instead of S1 he may come to S6 or S5. So this is the way you resolve it. So basically, if there exists only one slot, one hash table and specific number of places, but you are trying to insert two or more elements into the single slot where both the elements are different, that is x1 not equal to x2, then this will form a collision. But whenever you place instead of 10, whenever you place the hash table size as a prime number is the number which will be divided by itself and by 1 only. Okay, no other number can divide this. So whenever you choose a table size as size as a prime number, let's say for example hash table size is 11, which is a simple and nearest prime number I am taking. So if you compute the same thing again, that is 40 modulo 11. So 40 modulo 11 is the value 7. That is 11 3 are 33. So 40 minus 33, remainder is 7. 60 modulo 11 is 5. 60 modulo 11 is 5. And at the same time, 70 modulo 11. 70 modulo 11 is 4. So you look at here, just by simply changing from the normal number to a prime number, that hash table size, we have avoided collision here. This is a simple technique. So the reason a recommendation has been made here. What is the recommendation? The first recommendation is it is a good idea to ensure that the table size is a prime number. Always, if the table size, if you want to consider as 100, better you take the nearest prime number. Okay, it is important to choose hash function carefully when the key is not a short string or integer. So always choose carefully the hash function, because if you choose folding, you need to do several foldings. If you choose mid square, you have to perform squaring. So if you choose a complex hash function, you have to do such many complex things. But whenever you choose a complex hash function hash calculation, our aim of hashing, that is the technique to implement the insertion and removal or searching of an element in a constant average time may be violated. So that is the reason it is a recommendation given here. The first recommendation is always you choose the size of the hash table as the prime number. Then it is always important to choose the hash function carefully when the key is not a short string or integer. Here, collision or clash. If two non-identical identifiers, here what are the non-identical identifiers? X1 and X2, which are not equal. Two non-identical identifiers calculate or produce the same address, then it is called collision or clash. So, example, X1 and X2 are two distinct identifiers and H is a hash function then the collision occurs if h of x1 is equal to h of x2 for all x1 not equal to x2. So this is the main problem in hashing. So because it is quite possible that you may get collision frequently even though you choose the hash table size as a prime number. The reason is if you assume that the next element to be inserted is 44, or if the next element to be inserted is around 80, then what will happen here? If the next element to be inserted is 80, then what can we do here? 80, 90, and 110. Then if you do like this, even though you have chosen the prime number as the hash table size, then 11 modulo 80 modulo 11, which is 77, and remainder is 3, and 90 modulo 11, which is 88, the remainder is 2, 110 is 0, and if I say 140, then 11 into some value. Okay, how much is the value? So 140 by 11. So 140 by 11 means here you will get 121 and 132. Here 8 will come. So whenever you got the 8, this particular index may also occupied with some other element. So whenever it is occupied with some other element, obviously the inserting element and the previous element may not be equal. Then thereby it will form collision. That means even though you use prime number, we can maintain not to have collision for some time. But if the more number of keys are coming into the data structure, then it is very difficult for us to control the collision. So that is the reason the main problem with this particular hashing is the collision. Collision means there exist elements x1 and x2 are the two distinct identifiers, and h is a hash function. The collision occurs for whenever the h of x1 is equal to h of x2 for all x1 not equal to x2. So this is what the problem with the hash table. So the hash table is a very good data structure which will give us insertion, searching, and deletion of an element in constant average time. Up to this, it is fine, and we have seen various hash functions to compute the index value to which the key can be inserted. In that, we have find that the modulo operation based hash functions are more suitable for our operation. Whenever you choose modulo operation, then it is always recommended to choose the hash table as the prime number. So all these things we have seen, but still we find that as number of keys are coming into the to be inserted into the data structure, then there is a problem called collision. So in order to resolve this collision, we have two strategies. One is which is also said to be collision resolution methods. There exist several methods for dealing with the problem of collision. The first solution is separate chaining or open hashing. Second method is open addressing or closed hashing. Here separate chaining or open hashing means openly the hash values will be inserted into the elements. This will simply look like your multi-list. So if you have an index, if two elements are having the same index, then they will be inserted as a multi-list fashion. Say for example, at an index 2, there exist two elements to be inserted. Then at the index 2, there will be a single linked list will be formed, so that the elements will be inserted in a single linked list fashion. Overall, the data structure will look like a multi-list. Second method is open addressing and closed hashing. So the elements will not fall out of the hash table. However, all these elements will be remained within the hash table address itself. Where in case of multi-list or the separate chaining, so the name is telling you that there is a separate chain. That means from the index there is a chain will be formed. So that chain will be created. Okay. Where in case of open addressing and closed hashing, all the elements will be within the index values, within the buckets only. So they will not come out of the buckets and will form a separate link. So this is what the basic idea of these two methods.